Can you identify yourself? The two people have given the opportunity to record. Hello. Oh, I just gave you the opportunity to record and you are not owning up. May I know the two people who are recording, or you've put it in the chat? Please, can you hear me?
Yeah, sir. It seems Richard is recording. He's put that in the chat. Richard.
Okay. Right. Okay. That's fine. So please contact Richard. Okay, and then okay. Collect it. So we'll be looking at data science. Okay, like a bird's eye view of it, and then we will look at the business analytic process. Okay. We will also look at introduction to R for data science. So basically, with my courses, I'll be using R. Okay. I'm aware that you've started already with Power BI. Okay. You'll also be introduced to Python. So putting everything together, by the time you finish with this program in its entirety, you'll be equipped with the necessary skills to handle so many data science tools, right? So mainly we'll be using R. Okay. So data exploration and manipulation with dplyr. Okay, we'll be looking at data visualization with ggplot2, and then association rule, a priori algorithm, and then we'll look at k-means clustering as well as hierarchical clustering. Okay. So mode of delivery basically is hybrid. So we will be doing some online as well as face-to-face. Okay. So any questions on the course outline? And these are the reading materials, okay? So you can easily get them. Alligator and NIAC, okay? Business analytics using R practical approach, okay? And then you can supplement it with Globos and Jose, okay? And also one by O'Neill. Okay. Any questions? Any questions? Any questions?
Nana, please.
Yes.
Please, will we have a similar setup on the virtual learning platform so that we can access some of these data sets there?
Do we have what?
Would we have a similar setup in the virtual learning platform so that we can go there and
basically,
download?
I'll be sending you the slides. So if you say virtual learning platform, for my courses, everything that you need, I will send it to you directly. So
Okay.
unless
Thank you.
there is something that on the virtual platform that we are not handling, then I can see to that. But everything that you need, I'll make sure you get it. Okay, directly from me. Okay.
Okay, thank you.
And please, this course, all my courses are very practical oriented. Okay, so the way this program has been modeled, we don't want to just give you the theoretical aspects, because this one you will be going to the world to really solve problems. So you need to get your hands dirty. Okay, so let me reiterate this right from the word go. Okay, though we are starting as if nobody has done this before, okay, some of the concepts and stuff like that, but you should be prepared to work. Okay, we'll be doing a lot of practical stuff. So, and then we combine it with the theoretical aspect as well. Okay, okay. Have you downloaded the R? I saw on the platform that Dr. Sebe gave you the link to the R studio. Oh, okay. We'll talk about that later. Okay? Probably when we finish this. Any questions? Any questions? Okay. So let's look at the overview of data science. after completing this unit, you should be in a position to explain the concept of big data, what we mean by big data, and then the parameters of big data. Okay, we will also look at some of the terminologies, okay, such as data analytics, big data analytics, data science. You know, people use it interchangeably, okay, but there are slight differences between them, okay. Then we'll get an understanding of some of the big data analytics tools, and then distinguish between supervised and unsupervised machine learning, and then benefits of big data analytics. Okay? So, big question, what is big data? Okay, so I'm sure that the way this buzzword have been moving around is one of the things that attracted you to come and do this program. Okay, so big data, big data. So when we say big data, we're looking at applying techniques, okay, as well as technologies, okay, in order to derive hidden values from large data sets, okay, large data sets that are diverse, complex, okay, in every aspect, okay. So you might have various types of data, okay, various types of data, and traditional ways of uncovering hidden patterns within this data cannot be applied to the type of data that are coming out now, okay? So in the past, you have like a relational database or something, okay? And you just, everything is organized and you just access it, query it, and then get the information that you want. But this time around, even the speed with which data is being churned out, okay, we need new ways, new forms of inquiring into this data to be able to get insights from this data to help us in our decision making. Okay? So big data refers to these techniques and technologies that we apply in order to ensure that we unearth hidden patterns and values in our data sets. Subich also refers to big data as ones that are not being able to be captured, stored, or managed by typical software tools. Okay, I just mentioned it just a while ago, right? So traditional relational databases will not be able to handle big data, okay? Because it goes beyond the size of the data. We're also looking at how heterogeneous the data is, okay, and how complex the data is. So our typical traditional softwares will not be able to handle the kind of data that is coming out now. Okay. Any questions? Any questions on this before I move on? Any questions on this before? Yeah. So let's look at the parameters of big data. When we say big data, what are some of the things or the characteristics of big data? When we say big data, what are some of the things we're looking for? Okay. So Langley came up with the 3 V's. Okay. He came up with the 3 V's. That is volume, variety, and velocity. Okay. So obviously, big data means that the volume is huge. Okay. So large amount of data reaching levels such as megabytes, gigabytes, terabytes, petabytes, and so forth. Okay. So here we are talking about large volumes of data. Okay. For instance, if you take Google, the number of data, the amount of data they are able to turn out within 1 minute, okay, it's so huge. Okay, it's so huge. So in terms of volume, these data we are talking about are huge. Okay? And sometimes, so it's not about the volume per se, but the variety, how they are heterogeneous, across individuals and data types. So you might have various data types. All right. Okay. Might have various data types that have been put together. All right. And as a data scientist, you realize later on that you'll be pulling data from different sources. Okay. And then you put them together. All right. Clean them and then process them into a format that is to be able to be analyzed in order to get the information that you want from this. So sometimes it's not really about the volume, but the variety of data that comes in. Okay. And also the speed with which the data comes in. Okay. It's also an issue. So a typical characteristic of big data is also the speed with which data is generated. Okay. Aftab also came up with in addition to the 3 C's, okay, that veracity is also a characteristic of big data, okay, because you are getting data from different sources. There could be inconsistencies within the data. There could be missing values within the data, okay, or repetitions and stuff like that within the data. Okay, all these things come together and the data has to be processed. But using traditional softwares will not be able to cut it. Okay, so you should be able to use newer forms of big data analytics tools to be able to handle such type of data. Okay. He also talks about value. Okay. This is the potential insight that an organization may harness from the data that is being processed. Okay. So Revelis also talks about the variability. Okay. The variability. So it's not only about the speed, but the inconsistencies of the speed with which the data is stored in the system. All right. And visualization, you saw visualization today, how you'll be able to apply Power BI. There are various visualization tools. Okay. Power BI is one of them. You could also use something like Tableau, okay, to visualize your data. So these are visualization tools that are able to handle big data. Okay. So, and what makes it very interesting and insightful is the way it is interactive. Okay, very, very interactive. So you can plot various visualizations without the need for coding. Okay, though there are aspects of coding within Tableau and Power BI, but normally what they have on there is it gives you various options with which you can visualize data and communicate to your audience, okay, and communicate to your audience. Right. Other parameters of big data, validity, okay, where we talk about data accuracy and correctness, okay, and then other V's like data security, talking about vulnerability and volatility in your data, okay, how dispersed your data can be. Okay, so we have, so you get the trend. So there are so many V's that pertains to big data. Okay, so far we've spoken about 9 of them. Okay, so it started with the 3 V's, and then other authors also added some of the V's to it. Okay, any questions about the parameters of big data or the characteristics of big data? Okay, so when we talk about big data, now you should understand that we are not only talking about volume. There are other aspects of big data that makes it big data. Okay. So let's move on to the sources of big data. Where do we get big data? Where do we source it? Okay, so we will look at all these sources. You could get it from databases. Okay, you can get it from databases, right? Where you import data from There are so many types of databases. Some of them, please kindly turn off your microphone, okay, please.
Is it enough?
Right. Please, I'm sharing, so I can't see the person talking, but kindly put off your microphone. Okay. Mute yourself. Right. Okay, right. So we have databases, we have data warehouse, online portals, okay, and stuff like that. Let's see. Just a minute. Let's talk about the sources. So we can get data, okay, from traditional databases, okay, relational database or MongoDB or Hadoop or all these databases. You can also get it from a data warehouse, okay, a data warehouse. Can somebody tell me the difference between a database and a data warehouse? Can someone tell us the difference between the two, a database and a data warehouse? Please try. Can somebody try? What is the difference between a database and a data warehouse? Oh, my data scientist. Say something, say something. Okay, Richard, you are the one recording. Tell us.
Okay.
What do you think? Richard.
Hello?
Yes, Richard. Richard, if you do answer next time, I will not let you record. Next time, I will not give you that privilege. Okay, please, we are listening to you. Richard.
Yeah.
Just joking. Yeah.
Yes, sir. So basically, I think a database is anywhere that we can store data that we can use for a future task, possibly to retrieve, to do some analytics work on it. That is what I think data are. But for a data warehouse, it looks like multiple databases pulled together to serve as a combination of data from variety of databases to use. That's what I think data warehouses are. Thank you.
Okay, so you're looking at you're looking at a typical warehouse, and okay, you're not far from it anyway. Okay, please, yes, anybody else? Can anybody else try? Can somebody add to this? Can somebody add to this?
I think he has said it all.
No, he hasn't said it all.
Because I was also going to use the same
We are the one
example,
speaking,
the typical way.
That's right.
Louisa.
Louisa, okay,
Yes.
okay.
I was also going to use
All
the
right,
same example
okay.
of a typical warehouse and then the database. So.
Okay, all right. Yes, anybody else? Thank you. Anybody else?
Okay, so
Okay.
what I can say about a database and a data warehouse is the database serves as a connection or a pathway to saving data to the warehouse. Yeah.
Okay. Not really, but in some aspect it can be true. Okay. Let's take it like that. Oh, I'll give further explanation. Okay. But you are not wholly wrong though. Okay. Yes, please.
Good afternoon. This is Obed.
Obed, okay, please, Obed.
So what I think is the database basically stores data, structured data. That's what I think, as in structured form. whereas
Good.
the data warehouse stores both the structured, semi-structured, and unstructured data
Okay,
formats.
okay. Wonderful. Wonderful. Okay, wonderful. So yeah, I think that was quite good. Yeah, yeah. So anybody else? Yes,
Yes,
yeah.
sir. Can I chip in a little?
Okay, somebody. Okay, please chip in a little.
Okay.
So I think databases are usually like it's a storage. But for example, it can be a storage for maybe sales transaction in a given period, say this month, January.
Okay.
When you go into data warehouses, you find sales data from this month, last year,
Wonderful.
expenses data,
Wonderful.
purchases
Good.
data. I mean, it will cut across various databases.
Timelines. Okay.
Yes, that is what I wanted to add.
Okay. Okay.
Thank you.
Okay. Wonderful. Wonderful. So the last two answers have been brilliant. Okay. Anybody else? Last person. Last person.
So what I wanted to add was mostly databases are more of transactions within day-to-day
Good.
aspects, and
Yeah.
data comes in every time. But with data warehouse, we normally use it for analysis. So mostly deals with historical data, and we can even take from different sources, and then we clean the data so that we can use it for analysis purposes.
Good, good, good. I think the last three answers sums everything up. Okay, that have been very excellent. So, like they said, databases normally will be dealing with transactional data. Okay, so when you deal with transactional data, we can then export all of them into a data warehouse. So a data warehouse is quite huge, and it can take data on incremental basis. Okay, so you can have historical data in there, and we can be adding onto it as we go along. All right, we'll be adding onto it as we go along, and then we can assess. So that's why it becomes a source of big data. Okay, all right, because you can have in data from various sources. And one person also said that you can have it as a structured data or unstructured data. Okay, we'll come to that very soon. Okay, so with data warehouse, is able to store various types of data, whereas in a database, normally you're looking at structured data. Okay, right. For those who don't know the difference between structured data and unstructured data, I will explain it in a very short while. Okay. Okay, so another source of big data is online portal content. Okay, so we can get data from there. Okay, and then point of sale, right? Can get data from there. For instance, when you go to your malls and then you buy something and it's scanned, it goes straight to a particular database, and then all the sales that have been made for that day are stored in there. Okay. We also have other sources of data like smart meter data, video sources, image sources. Okay, all these are sources where we can get data. Okay. We also have natural language processing. Okay, where we look at tests, just tests. Okay, we also get data from social media. Okay, or RFID, okay, radio frequency ID system data. Okay, audio is also another form of data, and then clickstream, and then GPS data, spatial data, post, web blog post, and stuff like that. Satellite imagery, wireless sensors, simulation data, spatial data. All these are types of, are sources of big data. So you know what we are dealing with. So when we talk about data, big data, it can come from any source. depends upon what you are doing. Whenever hurricane was coming, okay, announcement was made that a hurricane was on the way coming, the sales for beer always went up. Okay, but you know, you will notice, you will be wondering why hurricane and beer, they don't have any connection anywhere. Okay, so like putting together the sales of the type of sales for the store, and also information from the weather. Okay, by combining these two, we're able to ascertain that whenever hurricanes are announced, okay, or hurricane is on the way coming, there is I don't know why that is, but that is what the data told them. Okay, so you can, all these sources could be meshed. Okay, so you can have just one source where you get a lot of data from that, or you could take data from various sources and then mesh them. All right, and then mesh them to give you a very comprehensive overview of what is happening. Okay, sometimes the values that you, or the insights that you derive from the data on its own, it will never come to your mind that by combining one or two types of data, this is the insight that you get. All right, so it tells you the inroads that data science is making. Okay, and no wonder it's one of the hotcakes around. Okay, any other question? Okay, so let's look at some of the terminologies. Okay, many people use it interchangeably. Okay, but there are slight differences. So when we talk about data analytics, here we're looking at analysis of data, whether it is huge or small. Okay, to understand whether there are some patterns in it that we can derive from the data. Okay, now when we say business analytics, here we are looking at using the information from data analytics to inform business decisions. Please, does it make sense? Okay, so data analytics is just looking purely at the data. Okay, and business analytics is the application of data analytics in order to in order to make business decisions. Okay, so everything is put in the business context, right? And then we have big data analytics. So here we've explained big data already. Okay, so if you have big data and then you are performing analytics on it, okay, so here you obviously require a very huge amount of storage to store your data, and then you have to know the kind of big data analytics tools to apply on the data. So you need to know the tools of storage. Okay, so if it's a data warehouse, you need to know how to build one or operate it. Okay, extract data from the data warehouse and then apply big data analytics techniques, okay, on this data that has been stored in order for you to get the needed insights that you want to get from your data. Okay. So basically, when we talk about data science involves everything that we've spoken about. Okay, and it goes a step further. Okay, so here we're looking at it's like a three-way intersection, okay, from statistics, mathematics, and then computer programming. Okay, in other books you find that it is a combination of statistics, computer programming, and engineering. Okay, yeah, okay, they are the same things. Okay, so data science apply. So apart from analyzing the data, okay, we go and then look at the underlying processes, okay, how they are used, okay, and then we apply statistics, okay, to, so whatever we are doing, whatever decision we are coming to, okay, having delved into the data itself, okay, we apply statistics and also computer programming stuff, okay, to interpret and also give us insight as to what the data is telling us. So it could be used for either descriptive analytics, it could be used for predictive analytics or prescriptive analytics. I'll explain all those in a short while. Okay. So let's see where data science or big data analytics are used in business. So many areas. Okay, can be used in marketing and sales, human resource. Okay, so marketing and sales, we can be able to, for instance, how to arrange, let's say, things within the market. Okay, we can, for instance, use association learning, which we will do this semester. Okay, to know which goods go together, which item sets go together. All right, and then we'll be able to arrange stuff within the market. Okay, we can use, have you seen sometimes when you watch movies, they will recommend another similar movie to you. Have you come across those instances?
Yes.
Yes, sir.
So behind the scenes, they use association rule mining, okay, or association learning, okay, to associate similar movies. Okay, so they work, all the algorithms are working behind the scenes to recommend other similar things to you. Okay, so if you have websites, you could sometimes you go to a website and they tell you that, oh, people who visited this site also visited that site. Okay, behind the scenes is using association rule, okay, learning to do that. Okay, we can use, let's say, clustering to segment our customers in terms of marketing, and then craft specific. Please kindly put off your microphones, okay? If you are now joining, kindly put off your microphones. All right. Hello. Please. Okay. Please, every time we join, make sure that you put off your microphone, other than that you disturb the class. Thank you. Okay, so we can use various techniques. Okay, so let's say when it comes to customer segmentation, we can use clustering techniques, which we will do this semester as well, to segment our customers. Okay, we can use predictive analytics, for instance, to determine, to predict whether an employee will stop the job, will leave the job, or will stay, or a customer will terminate his contract or not. Okay, in terms of product design, service design, financial services. Okay, we can use to predict stock prices. We can use it to predict various financial stuff. Okay, and customer service and support. So the application of data science or big data analytics in all these areas is huge. Okay, even in spatial data, we apply data science. Okay, and then simulate what is going to happen in the future and stuff like that. Okay, so there are various areas where this has been applied. Okay, so looking at the framework of business analytics. Okay, so we have a combination, so we can, let's say, import data from our data warehouse, okay, or it could be from a database, okay, all right, and then we apply statistics to it, okay, so either using all these inferential and also descriptive statistics. Okay, can apply all these things to the data. All right, you can apply business intelligence tools like Power BI, Tableau, and stuff like that. Okay, today, and then you even use R or Spark or SAS. All right, so all these things help you to unearth hidden patterns within your data. Okay, so I can pull data from my data warehouse and I can perform let's say a simple thing like regression. Okay, and then be able to predict, okay, how something is going to be affected. Okay, and then interpret it in the light of the parameters that the model is giving me. So here statistics will come in. All right, okay, and then all these things could be done within the platform of Python or R. Okay, and then we can apply other we can create visualizations and create dashboards to communicate our findings, okay, of what we've done. So I'm sure by the time we are through with this semester, if you take your experience from other models and put it together, you realize that these are the things you will be doing. Okay, these are the things you'll be doing. Okay, any questions? Any questions? Okay. Okay, so let's look at the types of big data analytics. Types of big data analytics. Types of big data analytics. So we have descriptive analytics, we have diagnostic analytics, predictive analytics, and prescriptive analytics. Okay. So next semester, we will do predictive and prescriptive analytics. Okay. So everything we do this semester basically will be around descriptive and diagnostic analytics. All right. So what is the difference between these types of analytics? Okay. So for descriptive analytics, they tell you what is happening now. Okay. They tell you what is happening now. So basically, when we do explorative studies, okay, in our data exploration, you will realize that it gives you information. Oh, please kindly put off your microphone. How many times do I have to say this? Please, can you locate the person who is talking? Please. Let's show respect to our other colleagues, okay? Make sure that every time you mute yourself before, unless you want to ask a question, then fine. If not, ensure that every time your microphone is off. Okay. Right. So descriptive analytics tells us what is happening within the data. Okay. What is happening within the data. So having identified what has happened, diagnostic analytics would like to inquire why it happened. Okay, so that is where, so out of descriptive analytics, we get diagnostic analytics. Okay, and then predictive analytics also tells us what is likely to happen. So this one is future oriented. Okay, what is likely to happen. And then prescriptive analytics is, so once I know what is going to happen, what do I do about it? Okay, so here, information. So you see that prescriptive analytics also comes from predictive analytics. Okay, right. So this one is based upon what we have predicted. Okay, what strategies are we going to put in place? What options do we have? Okay, to ensure that we get the needed outcome. So that is where your prescriptive analytics come. Please, any questions about the types of analytics? Any questions about the types of analytics? Any questions?
No, please.
Okay. Yeah. So let's look at some of the big data analytics tools. Okay. So you will collect data, you will process them. Okay. You will analyze them, you will visualize them. Okay. What are some of the tools that can be used? Okay. For all these different steps. Okay. Within the data analytics framework. Okay. So in terms of data collection tools, we have tools like Symentra, okay, OpenText, Tracker, SAS, sentiment analysis, okay. All these tools, and there are so many tools, okay. These are just a few of them, okay. Other tools for data processing, we have MapReduce, Hadoop, okay, Flume, Spark, Tableau, Pig, okay, Apache Spark, SAP HANA, all these, MongoDB, all these are data processing and storage tools. Okay. In terms of analytics, we have Spark, you have R, you have Python, okay, you use RapidMiner, Minitab, H2O, NIME, Hive, SPSS, all these are tools that are available to you. And in terms of visualization, we use Tableau, Power BI to help you visualize. Okay. So I'm sure for our course, we'll be using R throughout. Okay. I'm sure in your journey as a data scientist, you come across some of these tools. Yes, yeah, you wanted to ask something?
Yes, what influences the choice of tool? Is it just organization or some of the tools are better than others?
Oh, no, these are different companies that do these tools. So there are some that are for extracting, let's say, test data, okay, like Symentra, for instance, okay, and then it will do sentiment analysis for you, okay. There are some like something like Hadoop, for instance. Hadoop and Spark, they are able to take various types of data. It doesn't matter where it's coming from, okay. It could be data. What I mean is like data formats, okay. It could be a JSON, it could be XML, it could be CSV. What type of data that you can get? Hadoop will take it and then it will be able to interpret it, process it, and stuff like that. So it depends upon you and what you can afford. Because all these things, a few of them are free, but it's not all of them that are free. Okay, so from what I know, Python, R, these ones are free. MongoDB is free. Okay, Hadoop is also free. Hadoop and MapReduce are also free. Okay, so MongoDB, yeah, I've said MongoDB already. Tableau, they have Tableau Public. Okay, that one is free, but the main Tableau is not free. Power BI too, the desktop is free, but they have other versions, higher versions that are not free. Okay, so it depends upon you and what you want to do. Okay.
Okay, thank you, sir.
Okay, you're welcome. Okay, so let's look at some of these techniques. Okay, we'll just have an overview of them. So the techniques basically is linked to how do I say this? It's linked to whether it is the techniques are linked to the types of analytics. I don't know whether you get me. So we have supervised machine learning and then unsupervised machine learning. Okay, so the types of things that happen under supervised machine learning, we can connect it to some particular types of analytics. Okay, unsupervised machine learning can be connected to some types of specific analytics. Let's see. So first of all, let's see what we mean by supervised and unsupervised machine learning. So look at these questions. Do our customers naturally fall into different groups? Okay, so here we don't know. Okay, we are just asking a question whether our customers fall into different groups. So we don't have any target in mind. Okay, look at the second question. Can we find groups of customers who have particularly high likelihoods of canceling their service soon after their contracts expire? Okay, so here, if we are going to find out those customers, that means we have a target in mind. And the target is to find out those who have a high likelihood of canceling their service as soon as their contract expires. Please do get a difference. So the first one, we don't have any target in mind. It's like, okay, we now want to see whether our customers are segmented, whether they fall into different groups. So we don't know. Until we perform the analysis, we will not know. Or we perform, we perform the analysis, we will not know. Okay. But the second one, though we don't know, but we have a target in mind that these are the people we are looking for. Okay. So for the first one, because there is no specific purpose or target, okay, that has been specified for the grouping, okay, this type of learning is called unsupervised learning, okay, unsupervised learning. So we don't have any target in mind. While the second one is supervised learning because we have a target in mind. The target is defined, okay? So will a customer leave when their contract expires? Okay, so we'll be looking at these people. So that is the target. So whenever you have a target in mind, then you are dealing with a supervised machine learning. Okay. If you do not have any target in mind, okay, then we are looking at unsupervised. Okay. In some other books, you come across terms like unlabeled data. So unlabeled data is unsupervised machine learning. And then labeled data is supervised machine learning. Okay, because we have labeled the target. Okay, so when you've labeled the target, then we are talking about supervised data mining or machine learning. And if it has no target, we would now want to see if there are some groupings or we want to see insights. Okay, but we don't know what we are actually looking for. Okay, then it is unsupervised. Okay, any questions about supervised and unsupervised? Okay. Okay. Good. So, like I said, the type of technique that you use, okay, also determine. So if it is a supervised machine learning, there are some particular techniques that go with it. Okay, and if it is unsupervised too, there are some particular techniques that go with it. So some of the supervised machine learning techniques are linear regression, okay, decision trees, regression trees, random forests, k-nearest neighbor, artificial neural network, naive Bayes. Okay, so these are some of the supervised machine learning. So all this, normally you will have a target in mind, okay, because it is supervised machine learning. Okay, you have a target in mind that you might want to deal with. Okay, so most of these things we will tackle them when we are doing predictive and prescriptive analytics. And then we have unsupervised machine learning techniques. So here we're looking at clustering, okay, association rule learning. Okay, so these two we'll be doing this semester. Okay, so you will realize that on supervised machine learning, here, class train, we don't have any target in mind. We now want to see if our data fall into clusters, okay, or groups, all right? And then association rule, how item sets relate with each other, okay? We will not know until we create a model for that. We will not know, okay? So after we create a model, then we'll be able to see that, oh, item A relates with item B, or item BC relates with item XYZ, okay, and so forth, okay? It's very, very interesting, and we'll be doing it very soon, okay? On the,
for instance, with the customers, if they first use the unsupervised one by grouping them into different groups, can you then apply a supervised one of targeting a particular group, or when you use one, you can't use the other one?
So what can happen is that you can start with unsupervised. You don't know, all right? Then after you've done it, and then you see that, okay, they fall into this particular groups, then you can apply supervised machine learning techniques to it to focus on a particular group. Now you know the groups that are there. Have you seen? So after you've done the unsupervised, and then you see that, okay, this one falls into the group. So there's, in fact, 3 groups. All right. So now let me apply supervised to group 2 or group 3 or group 4. Have you seen? So, okay. So you can do one, and then after it leads you to the other. Okay.
Okay, thanks.
Yeah. Yes, please. I saw someone raise their hand. Okay.
So,
all right. Yes.
It's a follow up to what he asked. So when you do the unsupervised, the example you gave, and you have the clusters, and you choose group 2, does that mean you have to go back into the data and pick only the group 2 data set to do the supervised?
Yes, so the clusters will give you, all the group 2 will be grouped together.
So their data set right from the bottom.
So let me give you a typical scenario. Okay, so you have a marketing firm, okay, or you have a shop. You don't know the kind of groups that your customers fall into. Have you seen? So you can do an unsupervised learning to see the specific groups that you have as customers. So let's say you do it, and then you say that, okay, customer group 1 you have from the data, group 1 are people who are middle income earners, who live about 25 kilometers from the shop, okay, and then who normally shop on weekends. That could be group 1, okay. Group 2 will be people who are middle level, low level income, okay. They always buy goods that are about to expire, where we have reduced the price, okay. They don't come in on weekends, okay. Probably they are working somewhere, so they normally come on weekdays. This is just an example. So let's say you have these 2 groups, okay. So now your data has told you that you have these 2 groups. So based upon the unsupervised machine learning, you've been able to identify these 2 groups. Now, the ones in group A, we can say that, okay, what kind of promotional bundle can we do to target group A, especially those who are high income earners, who buy a lot of stuff, okay? What promotion can we do to target them? So we can put together, some number of items, and then do a promotional bundle. So that one is targeted at that particular people. So that one is, so you realize that now we are using supervised, okay, to target people we have identified.
Yes.
Does it make sense? So yes, that is a literal, explanation I can give for that.
Yes, it makes sense perfectly. But then I wanted to understand. So with the same example, if we have about 100 customers from the beginning and we segregate them into group 1 and group 2, we come out to find out that group 1 are made up of 50 customers. So in the supervised learning, do we go back to the 100 data and pick the 1, 2, 3 to the 50 and come and analyze them separately? Or we still take the whole data set of the 100 and
no. You just focus
on
on that particular type of group. So we will not. So now we will not be focusing on, because if you are going to do something, you are only doing it for that particular group. If you are going to do a promotional bundle, for instance, is that particular group you are targeting? Do you get it?
Okay. So there is a way to separate the data into 2.
Oh yes, we will do clustering. You will see.
Okay. All right. Okay. Thank you.
So you see that all the groups have been put together into various clusters. Okay, we'll do clustering this semester.
Okay, thank you.
Okay. Please, any other question? Any other question? Okay. Let's look at the benefits of big data analytics. Okay. There are so many benefits, and one of them is that it helps you to obtain new knowledge. Okay. All right. Because of the tools that you apply, okay, it helps you to unearth hidden patterns or insights within your data. Okay, it helps you as an organization to help you to understand your environment better. Okay, for instance, if you are using clustering technique to group your customers, it helps you to know your customers better, isn't it? Okay, and then it's been argued that big data analytics, those who apply it have superior performance than those who do not, because those that apply BDA techniques arrive at, data-driven decisions, unlike others where it's more of guesswork and intuition. All right. So application of these techniques help organizations to perform better. Okay. And Raguseo segregated these benefits into strategic benefits, okay, strategic benefits, transformational benefits, transactional benefits, and then informational benefits. Okay, so we can have a look at them. So for strategic benefits, talks about aligning IT strategy with business strategy. It helps you do that. It helps you provide better products and services, okay, and then enables quicker response to change. Okay. Transformational benefits, because of these new tools and techniques, it helps employees to improve their skill level, okay, helps create business opportunities and expand your capabilities, right, and help you improve your business model. Okay. So these are all item descriptions that fall under transformational benefits. Okay. Then transactional benefits, okay, helps you to reduce operating costs because you can analyze them, break them down, and see parts that do not add value to your whole process. Okay, avoid the need to increase the workforce. Okay, now with the emergence of AI, it's creating a lot of problems for people, but data scientists will survive. Is that not so? Okay, so increasing return on financial assets and employee productivity. So all these are item descriptions relating to specific benefits. Let's look at the informational benefits. Okay, so it helps to access data faster and easier. Okay, you'll be cleaning the data, removing missing values and stuff like that. Okay, so it helps with data accuracy. Okay, and then normally you will process the data into a form that can be analyzed further. Okay, so it helps you to reuse your data. Okay. Right. Any questions? Any questions on what we've done so far? Any questions on what we've done so far? Okay, so let's go for a break. When we come, we continue. But I'm here for the next 5 minutes. If you have any question, you can ask me. So we are coming back to 2:40. Let's come back 2:40. Okay, you have 30 minutes break. Or you want to take a shorter one, then we finish quicker. It's up to you. What do you want?
We'll come back at 2:40.
Okay. By the meantime, is there any question? Is there any question you want to ask based upon what we've done so far? Is there any question on it?
Please.
I also wanted
Okay.
a shorter break so that we close it.
Okay, then decide among yourself and let me know. Okay. All right. Okay, so I will see you at 2:40 and then we continue. Thank you.
Okay, sir. Thank you.
Okay, thank you.
Hello, sir.
Yes.
Yes, just a quick one. You see, some
Okay.
of us are coming from a background where these things are very new to us. So, in as much as possible, we try to get into it so that we can understand it better. So,
Okay.
I would probably recommend some maybe online tutorials or something for us so that we can pick from the scratch and then understand it better if there is anything like that. So that
Oh,
within
okay.
at our leisure time, if it's about maybe big data, maybe a site that you can read something.
Okay, okay, all right.
that-
In fact, what we've done so far is just the theoretical aspect. When we get into the practical stuff, you will have loads of opportunities to practice. Okay, so these are early days.
Oh, okay.
So as for this reading, you can read them, and then I've already recommended some books in the course outline. You can have a read on them. But we will go into R proper. We've not touched that at all. So we'll go into that and then we'll see how it goes. Okay.
All right. Thank you very much.
Okay, so see you at 2:40.
Thank you.
Variety. Okay. And then other people added other aspects of it. So the volume might not be necessarily big, but the data varies a lot. Okay.
Okay.
So
Okay.
it can qualify as a big data. So it's not really about the volume.
Okay. Okay.
Okay. Just a minute. I'm trying to share this. Okay, so let's look at the process, the big data analytics process. All right. So we'll be looking at various types of processes, including let me correct this. UDD. so we're looking at various processes, and various authorities have come up with different steps. Okay, they all refer to the same thing. It's just the names that they've given to it. So let's look at a couple of them. Okay, so we have KDD, we have CIMA, we have CRISP DM, we have analytics life cycle, and data science life cycle. Okay, but before the different types of data. Okay, so we need to understand our data, and I'm sure you are all aware of the fact that you can get data from primary source or a secondary source. Okay, now there are other sources of data. Okay, that is structured data and then unstructured data. Okay, structured data and unstructured data. Let's have a look at structured data. So here we're looking at data that is well organized and accurately formatted. Okay, you normally find this in databases, or you see when you do your, especially in Excel, okay, you see that you have columns, you have rows, okay. These are all structured data. Okay, these are types of structured data, okay. It's the same thing when you go into a typical database system, okay. You will see them there, okay, right? So a typical structured data is what you have here. So let's say in column A, you have the user ID, okay? Column B, you have the last name. Column C, first name. D is the column for birthday. E is the country of origin, date of purchase, and so forth. So you see that this one is very well organized. So each column has a particular data type that it is taking. Okay, so it is arranged in columns and rows. Okay, so here one row tells us about Michael Davidson. So everything about him we know. We know his last name, we know his first name, we know his birthday, where he comes from, the dates that he made the purchase, and the amount that he made. Okay, so this is a typical structured data. Okay, so when we talk about structured data, it has rows and columns, and it is nicely organized. Okay, like this. Each row or column has, so each row will identify is for one observation. Okay, each row is for one observation, whilst the column is for various fields, okay, of that particular observation. Okay, so this data can comprise both text and numbers. So here we have text like in name and Michael, and then in name like last name, first name, and then numbers like the user, the purchase ID, or the birthday. So all you see, the birthday is numeric, okay, and then the country is text. So you have text, you have numeric data, you have text data, all combined, okay, into what we call a structured data. Okay. Any question on structured data? Any question, please? Any question? So let's look at unstructured data. So unstructured data relate to data that is not structured in a predefined way. Okay. So this could be your PDF, it could be email, it could be text file like social media posts, it could be video, images, audio, sensor data, metadata, and geospatial data. All these are unstructured. So it is not structured in rows and columns like this. For instance, when you take your email, it's not like this. It's written in text. All right. So that is the difference. Or a video. Okay, it doesn't come in any predefined format. Okay, or audio. All right. So all these are unstructured data, like your pictures and MP3s, and all these are unstructured data. Okay. And then we have semi-structured data. So semi-structured data has a component that is structured and a component that is unstructured. Okay. In our dealings, we'll come across some of them. So a typical JSON file, for instance, is semi-structured. All right. So you can see on your right-hand side, okay, that it includes tests, okay. But within this, though it is not in columns and rows, okay, we can actually sift through and then get the information that we want. So some of them are basically structured, okay, and some are, unstructured. Okay, so a typical JSON file is a semi-structured data. Okay. So both structured and unstructured data carry great value for business, okay, of diverse fields and scale. So as a data scientist, you should be able to know how to combine the two, because as you go to the field, it's not every data that will be in a database. It's not every data that will be in a data warehouse, for instance, okay? So there are some that will be in the form of text, okay? And they have to be analyzed. Okay, so you need to find out how you can combine both structured and unstructured data and then apply your analytics or business intelligence tools to it, okay, to get the needed insight for your company. So a typical data warehouse can house both structured and unstructured data. Okay, so if you build a data warehouse, okay, you can import into it unstructured data, you can import structured data, and then you can combine the two within the data warehouse, okay, and apply some analytics techniques to it. If it is prescriptive analytics you are doing, it to be able to predict, or descriptive analytics to be able to tell you what is happening and so forth. Okay, we'll have a look at all those. Okay, please, any questions about structured and unstructured data? Okay, right. So let's look at some of the analytic process models. Okay, so we have what we call the KDD process model, or knowledge discovery and data mining, KDD. Okay, so this process model consists of 5 steps. Okay, it consists of selection of your data, pre-processing the data, transforming the data, mining it, and then evaluating the data. So these are the 5 steps. So you have data, okay, you source data, or you collect data from the data source, okay, so that will be your target data. After the data has come in, it might be messy data, so it has to be cleaned, okay. So that is the pre-processing stage where you clean the data and then ensure that it is in a good form to be analyzed further. Okay, so the data can be transformed. Okay, so sometimes the raw data has to be worked on, and then we transform it into a suitable format. All right. Okay, and then after we have transformed it into a suitable format, then we mine the data. Okay, and then as we do that, we'll be able to, so we do that applying some specific VDA techniques to it to get the needed patterns or insights, which will increase our knowledge of the data. Okay, so this is the 5 steps, okay, of KDD. Okay, so it's knowledge, knowledge discovery and data mining. KDD. Okay, so we select our data, we pre-process it. Okay, pre-process it to take care of missing data or wrong data. Okay, we sort all those ones out, and then if it is not in a form that can be processed further, we transform the data. Okay, transform it into a suitable format, and then we explore the data, or we mine the data to discover patterns within it. Okay, so that is the process model. All right. Now, we also have the CRISP-DM. This is a very important model. Okay, so take note of it. Most of the data science projects use CRISP-DM process model. Okay, so it's something we really need to understand. Okay, so here, it stands for, the CRISP stands for Cross-Industry Standard Process for Data Mining. Okay, CRISP-DM, cross-industry standard process for data mining. Okay, this also consists of 6 steps, okay, or 6 iterative steps. Consists of business understanding, okay, data understanding, data preparation, modeling, evaluation, and then deployment. So if you see the diagram on my right, okay, so you need to understand your business. Okay, so it's not just, so as a data scientist, it's not just about data. No. Remember that every insight that you get from your data should be in the context of the business. Okay, so you are not just churning out insight from the data for the sake of it. No, it has to be in the context of the business. And how can it be in the context of the business if you don't understand the business? So whatever field you are in, or whatever project you've been given as a data scientist, you should understand the business, okay, that you are dealing with. You need to understand it so that every data that you get can be put in a particular context. Okay, so you need to have business understanding. All right. So business understanding, then it leads to what? Data understanding. So apart from understanding the business, the data that you gather, you should understand the data. You should understand the data. Okay. And that leads you to the next stage, data preparation. Okay. So if you don't understand the data, you cannot pre-process it. Okay. So here, the data preparation is equivalent to the pre-processing under KDD. All right. It's equivalent to pre-processing under KDD. So here, the data preparation is where we clean the data, where we transform the data if the need be. Okay, we deal with missing values, all right, and stuff like that. Okay, so we prepare the data in such a way that it will be suitable for further analysis. Okay, now after we have done that, then we generate a model, okay? Because whatever data we have prepared, okay, we need to run it in a model to see the results of the results that the model will give us. So this will depend upon the type of technique you are using. All right. So when we run it in a model, and it gives us the results, okay, then we can evaluate the model parameters to see whether, you know, it's giving us the needed insights. Okay, so when you run everything, you train your model, you work it out, everything is working fine, then we deploy. Okay, so this one is not really like linear in a way, because for instance, from the evaluation stage, you can go back. If things are not making sense, you can go back to your business understanding stage. Okay, modeling too, for instance, between the data preparation and the modeling, you see that the arrows, you know, go back and forth. Okay, so if your model is not fitting, then probably you haven't cleaned the data well. So you have to go back, clean the data well, and then do your model again, and so forth. Okay, so that is the concept of the Crisp DM. Okay, so when everything is fine, we deploy it. Okay, so all this write-up is to explain the various steps within the Crisp DM process model. Okay, so the data preparation phase covers all activities to construct the final data set from the initial raw data. Okay, so when you have the raw data, okay, after you've imported it into your space, okay, then we prepare it. Don't worry. When we start every data set that we take, we'll be going through this process. You will know how to prepare
the
how to clean the data, and so forth. Okay. Any questions so far? Yes. Yeah. Go ahead.
So you mentioned that the Crisp data model is not linear, whereby you can go back. The KDD, is it only linear, or with that one, can't you go back again?
KDD, you see, KDD also has, you see the arrows in between here. It comes across as linear, but you see that when you get into, you can go back. You see the arrows that is, I don't know whether you see my cursor.
Yeah, I can.
The arrow is on both sides. Have you seen? The down arrow is on both sides. So whatever you get, you can go back and then do something else and then release you to the next stage again. All right.
Okay. And the data mining part, is it with the KDD process? Is it only after the transformation does the data mining occur, or from selection to transformation?
So if you do your pre-processing and then there's no need for transformation, then go straight to data mining.
Oh, okay.
There are some, we will see. There are some data. Let me give you a typical example. Sometimes you get some data, the numbers are too huge. Okay. So you create a logarithm of that particular number in order to reduce its size. Okay. So we create a log for all those kind of data. Then, because there are some, let's say you get a particular data set, okay. Column A could be, let's say, 1, 2, 3, 4. Okay. So the unit differences between them is just like one unit or 2 units. And then you get another column whereby it's in 100,000s. Have you seen? So if you are to make comparison in that particular instance, your data will give you inaccurate reading. So in such instances, because some numbers are very huge within the data, you need to find the log, okay, the logarithm of all the ones that are very huge in order to reduce them so that you can make meaningful comparison. We will get there. We haven't gotten there yet. So there are some instances that you need to transform your data. All right. So when you pre-process it, you clean it. So, but if there's no need to transform it, please, my people, you need to turn off your microphone. So I've been saying this over, and please, can you identify the person saying that? Because I'm sharing my screen, I can't see the person talking. Please. I've told you several times to mute yourself, okay? If you are not asking any question, just mute yourself to be on the safer side. Other than that, you disrupt the whole class. Okay, yes, Emmanuel.
Okay, sir. Thank you. Please, can you throw more light on what the process model entails in general, like what really it seeks to achieve?
Process model basically is the process that you go through in order to derive knowledge from your data. So we are looking at various processes. All right. So we are looking at big data analytics process model. So it's just big data analytics process, okay? But there are different models of this process. So that's what we are looking at. I don't know whether I'm connecting.
All right, I'm okay.
Yeah, all right.
Okay.
So we have the KDD process model, all right? And then we have the CRISP-DM, okay, so which I've explained. Okay. Then we also have the CIMA process model. Okay, so this was developed by SCS. Okay, so this also offers an easy to understand process. All right. So what happens is that normally as a data scientist, when you are given a project, okay, you choose one of these processes to follow. Okay, so it's a step-by-step guidance as to how you can deliver on your project. Okay, so let's see the CIMA process. So here, it starts with a sample. Okay, so this is the stage where you sample the data from a source. Okay, you take data from a source. So normally it's not really possible to take the whole population, isn't it? So you might want to do some sampling. So you sample the data, but it should be large enough for you to derive some insight from it. Okay, and then you explore the data. Okay, you explore the data. Okay, so you realize that they are using just different names to refer to basically the same thing, because exploring the data, somebody might say pre-processing stage. Have you seen? Okay, so when you explore the data, you get to find out what the data is all about. Okay, are there any anomalies in the data? Okay, are there missing values in the data? Okay, how can we replace missing values? Do we need to replace them? If we replace them, will it change the mean of the data or what? Okay, so all these are issues that has to be dealt with. Okay, so remember that somebody is using the term explore. Somebody might say that it is pre-processing. Okay, see here they say modify. So this stage consists of modification of the data by creating, selecting, and transforming the variables to focus the model on selection process. Another person too will not use the word modify, they will use transformation. Have you seen? So, but it's basically the same thing. Okay, so here they also use the term. So you sample, you explore, you modify, and then you generate a model. Okay, you generate a model. So it's the same thing here. For CRISP-DM, there is a modeling stage. Assessing the data by evaluating the usefulness and reliability of the findings. Okay, but this stage does not add deployment. We see with CRISP-DM, it adds, there is deployment to it. Okay, so some of these, so you see that if you are to compare these process models, and there are some stages that as compared to another model, it will be merged together. Okay, while some there is further breakdown of the steps. So this comprises 5 steps, while the CRISP-DM comprises 6 steps. Okay, so that's the CRISP-DM. And then we also, the CIMA model. We also have another model, that's the analytic live process model. Okay, analytic live process model. So here, this was also developed by SCS. Okay, so they came up with the CIMA process model. Okay, and then they developed it further. Okay, they developed it further to create the analytic live process model. So here you ask a question. So a question will be the problem that you want to solve. Okay, you get the data, you prepare it. So preparation in this case will be the pre-processing. Okay, you explore the data, okay, to see whether there are trends and stuff like that in the data. You model the data, okay, then you ask the question again, and then implement the model, okay, and then you take action on them. So you see that it has 2 main parts. It has the discovery part that is on the left, and then the deployment part. Okay, so the discovery part is discovering insight from your data. Okay, so you ask, you prepare, you explore, and then you model your data. Then when you are moving to the deployment phase, okay, you implement, okay, your model, okay, you act on it, and then evaluate the results to see whether it's giving you your needed insight. If not, ask another question, and then the whole process starts again. Okay. So we have two main phases. We have the discovery phase, and then we have the deployment phase. All right. Okay. So that's for the analytic life process model. Any question on this one? And then there's another model. Data science life cycle model. Okay. So here, to the stages are business understanding, data acquisition and understanding, modeling, deployment, and customer acceptance. So you can see that this one has fused Krebs DM with it. Have you seen? So you have business understanding, data understanding, but here they add data acquisition, modeling, deployment, and customer acceptance. Okay, so in the middle here, you see Krebs DM here. Okay, so here you start by understanding the business, okay, understanding your data, and then you acquire your data. Okay. Now, after you've acquired your data, you deploy your data, and then so here you can see with the arrows, it doesn't follow a particular pattern. You can actually do your data acquisition understanding, and then you model your data, and then it goes to deployment. Okay. It's like most of they interact, the steps interact with each other. Okay, so at the modeling stage, here we perform feature engineering, where you can transform your data, whether it is text, image, or you select your data. Okay, sometimes you do not need all the data, especially if there are issues of multicollinearity. We'll come to that later on, where some data sets, some items within the data set are highly correlated. So if this one is rising, the other one is rising. So if that is the case, then we don't need all of them within the model. Okay, we can choose, we can see the one that has the most effect on our dependent variable, and then we choose that. Okay, so there are so many ways that can be done. We can use principal component analysis to do that. Okay, so we perform feature engineering, where we do feature selection and feature extraction and so forth. Okay, we do model training. Okay, you train the model, and then we have what we call training and testing data. Okay, we'll do all this. Okay, so these are terms flying about, but you'll be conversant with them very soon. All right, so we train the model, give it some data to see how it will perform, and then when we finish, we test the data. Okay, after that, we do model evaluation, okay, to see how the model is performing. Okay, now when we are done, okay, you do the deployment. So here the deployment is talking about how customers will, your clients, when you deploy it, your client will see whether the thing is working or it's not working. So if it's working, the customer accepts it, and then you come to the end of your cycle. Yes, Emmanuel, you wanted to ask a question?
Yeah, yes, sir. I want to find out, can data analysis be likened to data modeling? If no, can you explain what it actually entails?
Hey, Iman, take your time. Okay. Okay, so you say that is data analysis. Please go ahead.
Yes, I'm saying I want to know whether data and analyzing the data can be likened to data modeling. If that is not the case, what really is data modeling? Because I'll be hearing data modeling data. I'm trying to get it.
Okay. So in order for you to let's say, let me give you a typical example. You've heard of regression, isn't it?
Yes, sir. Yes,
okay.
Sir.
So regression has an equation. Is that not so?
Yes, Yes.
So it has the dependent variable y and then the independent variables with its coefficients, isn't it?
Yes, sir.
So that is the equation.
Yeah.
Now we create a model based upon that equation. All right. So we will create a model. So you will see how the model works. So we'll create a model based upon that equation. That will help us to predict the dependent variable y. Okay. So if it is regression, then that model will be based upon regression. So we'll call it a regression model. Okay. If it is a logistic regression, it will be a logistic regression model, which will be different from a normal linear regression model, because the formula for logistic regression is different from linear regression. Okay. So whatever you are doing, if we are using, let's say, a model like support vector machines. Okay, if you haven't heard of it, that's fine. But there is a formula. So there's a model. So each technique has what it does. Okay, there are some that do classification. There are some that do regression. Okay, so based upon what that particular technique does, it is modeled according to what it's supposed to do. So when we say data modeling, what we are trying to do is that we want to run the data based upon something. That thing is called a model. Okay, that thing is called a model in order for you to have a result. So if you want to predict, let's say, stock prices, what model are you using? Are you using regression or are you using time series? If it is time series has its own way of behaving. So we'll create a time series model. If it is regression, we create a regression model. Please, do you understand?
Yeah, yes, sir. Thank you, sir. I'm okay.
So it is based upon what we are doing. Okay. So we will come across we want to predict house prices. Okay. We can use, let's say, regression model to predict house prices. We can use, let's say, support vector machines to predict house prices. But when we finish, you need to evaluate the model to see which model gives you the most accurate information. And then you choose that particular model. So the fact that a model can be used to predict doesn't mean that you necessarily use that model. You want to use the model that gives you the highest accuracy in terms of prediction. Is that okay? So that is why it is important to know so many models, so that you will see how you will choose the best performing model. So normally we call them ensembling. You see where the model training is. Have you seen? You see where model training is? You see on the left-hand side, we have algorithms ensemble. Yeah? So ensemble is using so many models on one particular data and then choosing the best performing model. Is that okay? So that is why when it comes to deployment, okay, we are scoring performance, okay, in terms of the best performing model. That is what we have chosen in order to use for the customer. Is that okay?
Cycles that we are talking about, what informs the usage of a particular cycle?
What informs? Oh, in fact, it depends upon you as the data scientist, but there is the argument that all of them are really based on CRISP-DM. Okay, apart from the KDD, the KDD is okay, but it doesn't go deep enough. Okay, you see that it doesn't involve deployment. Have you seen? All right.
Yes.
It doesn't involve deployment, but the CRISP-DM involves deployment. When you come to CIMA also doesn't involve deployment. It just assesses the, so on practically on the field, most data scientists use CRISP-DM, and then other ones like analytic life cycle model, and then the data science, they all include deployment phases. Okay, so there's even the argument that they are all CRISP-DM, just that they have been presented a bit differently, but they all do the same. So basically, in choosing what you want to use, all of them will give you arrive at the same destination. Okay, just you need to really have a good grasp of CRISP-DM. Okay, the industry standard.
So for the purpose of our studies, do we really need to know each intricate detail for each of the cycles, or we should just have a concept of how each of them progresses till the deployment stage?
Oh, once you understand CRISP-DM, all the rest are just minor variations of CRISP-DM. You know, for our purposes, remember we'll be having an exam, so know all of them. So just in case. So just in case we get there, then you'll be able to answer the questions. Okay.
Okay.
But on the field, you know, having a good grasp of the CRISP-DM, you know, will see you through all your projects. Okay.
Okay, thanks.
You're welcome. Yeah, any questions? You are running very quick. I like that.
Yeah, hello.
Yes.
Hello, Doc. Yeah, so I've been analyzing or in going through all the modeling stages. I've realized I keep seeing data acquisition, but it does not speak more about storage or the platform used for the modeling.
Oh yes, so they are all implied. So when you acquire the data, you need to store it somewhere, isn't it? You know, when you acquire the data, okay. When you acquire the data, you need to. So here, data acquisition and understanding. So here you have the data source, you have the pipeline that you are using to import the data. So it could be batch or it could be streaming. So batch is that you import the data in batches, okay, or it could be streaming, so it's like continuous. All right, okay. So you could use various environment to store your data. It could be cloud-based, it could be a data warehouse, so data lakes and all that. There are types of data warehouses, okay, and then or it could be a database. All right, so all these are storage areas. Please do see with the environment, okay?
Yes,
and then we
yes,
have
please.
data wrangling, exploration, and then cleaning. So here we have structured data, how you clean it up and visualize it and stuff like that. They all come under data acquisition and understanding. All right.
Thanks.
Okay. Yeah. Any question? Any question? Yeah. So I'm sure with your course you will come across various database like Heidi SQL. You can use that to store your data. Some of them, like I said, some of them are free, so you can use like MongoDBs and stuff like. Some of them are free, others too are not free. So it depends upon that. So this is to equip you. This program is to equip you to perform data science activities. But remember that the journey does not end after this program. Okay, you will, as a data scientist, new tools will be coming on the market, so you have to get yourself conversant with all of them. All right. Okay, so basically, I think that's it. So we've spoken about KDD, CRISP-DM, SIMA, analytic life cycle, and data science life cycle. So these are all process models just these few ones we've spoken about. So you should be in a position to explain what each one does. Okay, so they are basically, some are just broader than others. Okay, so with the exception of KDD and then the CIMA, you realize that the CRISDM, analytic life cycle, and data science life cycle, they are basically the same. Okay, just that different. Most of them are based upon the analytic life cycle and data life cycle, or they are all based upon CRISDM. All right, they just added variants to it. Okay. Any question? Any question? Any question? Yes, don't worry. I will share the presentation with you. Okay, everything that we do, I will send you the slides. Okay, no worries. That's Ernest. Okay, I will send it to all of you. So Ransford, you will. What I will need from you later is to collect all the email addresses of your class. Send it to me so that when I'm sending the slides, everybody gets it.
Okay.
Yeah. Or you want me to send it to you and then you class, how do you want it? Do you want me to send it to you directly or send it to the class rep?
Any option you choose.
Okay. All right. Okay. I will see. Because now your class is you are many, so we'll see how it goes. Okay. Okay, but you still collect all the email addresses of everybody and then the names and then the email addresses so that I can send it to you accordingly. Any question? Any question?
Please, what about the course outline?
Yes, I'll send everything to you.
Oh, okay, all right.
I'll send everything.
And the recommended reading material.
Everything is in the course outline.
Okay.
Yeah, the recommended reading material is in the course outline.
On the virtual platform, I think you were one of the course you were able to get access to the soft copy. Yes.
Yeah, I'll send this. So that's what I'm saying. I'll say. Oh, you mean the book itself?
No, the soft copy of the book.
Okay,
I don't know whether
I will see if I can get a soft copy of the book and send it to you. But you can get it online. It's not anything.
Okay, see. Thank you.
Or any email that you choose, you can send. You can give me your school email, or it's up to you. All that is needed is that you get the slides. Okay. All right. So if you want to keep school stuff in your email, that will be fine. So preferably your school email. Okay. Preferably your school email. But any email will do for me. All right. Okay. Any question? Now, just a quick one. Have you all downloaded the R?
No, please. We're having some challenges with it.
Okay. So I think let's have about 5 minutes break. And then when we come back, we will see if we can use the time to download the R. And then so that tomorrow when we come, we start straight away. And then we begin to do some work. Okay. What challenges were you having? What challenges were you having? Or let's discuss that after 5 minutes. Let's get something to drink. Let's come back 3:35. Okay.
All right, Doc.
Okay.
And then we do the R. Okay.
All right.
But sir, is it R or R Studio? Are we getting R or R Studio?
Both. We'll get both. Okay. So I will show you how to go about it.
Okay, thank you very much.
All Okay. So you should have something like this. Okay. So I don't know whether some of you have downloaded it already. If not, then we can go through this together. Okay.
I see.
So first of all, what we need to do is to you can I don't know the latest version yet, but you can go to this, use this link, okay, our-project.org, okay, where you can get, it opens this interface for you, and then you click on download R. Okay.
Yeah, hello, sir.
Yes. Please go ahead.
The link that Doc sent gave,
yeah, it's the same thing. It also
version
take you to the
4.
website.
But when I installed the R, it gave me version 4.0.4.
It gave you 4.0.4.
Yes.
Okay. That's fine. Why?
No, it's rather 4.3.2. Yes, 4.3.2. Is that the latest one?
Then probably that's the latest, because 4.0.4 is about 2 years back.
Is the one you have? Okay.
Yes, mine is 4.3.0. Okay. So you go to the website. When you go to this website, okay, and then follow. Let me see if I can go there myself. Are you on the website now?
Yes, sir.
Okay.
Yeah.
All right. So if you want to get the latest, okay, so click on download R. So it should open something like this for you. So if you are operating with Windows, then follow the instructions. In terms of the crown mirror, I think Algeria is the closest to us, so you can use that for Algeria.
Okay, so mine doesn't have Algeria on the list.
What does it have?
Argentina, Australia, Austria, then Belgium, Brazil, then it follows. Let me see, African countries. I have South Africa here.
Yeah, choose South Africa.
Okay.
No, doesn't matter where you download it from.
No, it doesn't matter. It doesn't matter. But you choose it's a mirror, so choose the one that is nearest.
Okay.
It used to be Algeria, but I think now it's South Africa. Okay. So when it's done, you should have something like this. After installation, you should have something like this. So let it install, download it, and then install it. So when it's done, you should have something like this. This is the R console. Okay. When you are done, let me know. Okay, you can put it in the chat. Nancy, is there a problem? Is Nancy here?
Yes, sir. I'm here.
Yes. Are you facing some difficulties?
So it seems my WhatsApp group, it's not the ideal one.
Okay.
So I think I'll need help joining the WhatsApp group that you are feeding information to. But I've been able to download
speak to
the
Ransford.
R console.
Okay.
Ransford, all right.
Yeah.
I will do that. So I think I need to get the R Studio because I seem to have the.
Yeah. So download the console before you download the R Studio. So don't do the studio before the console. Okay.
All right, sir.
So do the console first. So when you are done, then we go on to the R Studio. But I want all of us to finish with the console first. Okay.
All right, sir.
The R Studio runs on the console. Okay. So without the console, the R Studio will not work. Yeah. Is it Delasi? I hope I'm mentioning it rightly.
Which country you said we should choose again?
You can use South Africa.
Okay.
Please, who has raised their hand? Is it Delasi? Were you the one I just spoke to?
Yes, please.
Okay. No, if you have it on Anaconda, you are good to go. Okay. Emanuela, if you have your R in Anaconda, it's fine. Okay. So the Anaconda gives you the option of working with Python and other stuff all in one place. So, but this one just downloads only R. Okay. Please, we can hear everything you are saying. Turn off your microphone.
Solomon, please turn up your microphone.
Okay. Are you all done? Please, if you are done or you already have it in Anaconda, let me know so that I know I can follow and see the number of people who have completed.
Laptop let me be. I don't know laptop at.
Okay, so Nancy is done. Emanuela is done. Or Emanuela, you are not done. Hello, please put off your microphone. Okay, Bernard is done. Isaac is done. Okay, so those of you who are done, you can go ahead and then download the R Studio. Okay, so after you install the R console, install the R Studio. Okay, so follow this link. Okay, so use the one I've sent to you and then copy it and then download the R Studio. Download the latest one, the latest version. Okay. When you finish, you should have something like this. Okay. For those of you who haven't finished, we are still waiting for you to finish with the console.
And please, should we close the console before installing the studio?
Yes, do the console before you do the RStudio. Other than that, it will not work.
I've done it, but I mean, as in closing the application before doing the.
Yes, close it, and then download the RStudio.
Okay.
Yes, sir.
And so I see you use National Park. Right.
All right.
So the information, yeah.
But,
All of it, number of
but
yeah.
nice.
Please, do you choose the desktop or the server mode?
Use your desktop.
Hello, Nana.
Yeah.
Please, which crown mirror should I use?
You can use South Africa.
South Africa. Okay.
Anyone done? Yes, Muslim.
Hello, Nana. Please, I've done the RStudio, but I'm having 3 windows open.
Okay, I will show you what to do.
Okay, thank you.
Hold on. Share your screen. Share your screen. Let's see. Muslim, can you share your screen?
Okay, a minute, I'm coming.
Okay.
Hello, Nana. Please, can you hear me?
Yeah, I can hear you.
Can you see my screen?
Yeah.
Okay.
Okay, so you see on your left-hand side, okay?
Okay.
Where your cursor is, okay?
Yes.
Go to where the console, have you seen console written, the console tab?
Yes.
Okay. Come to terminal.
Okay.
Background jobs.
Okay.
And go to the stream. You have 2 boxes there.
Here.
Click on it.
All right.
Yeah.
Okay. Thank you.
All right. So when you are done, you should have something like this, okay? The R Studio. When you finish, open the R Studio, you should have something like this. Okay? Just clean this. Okay, you should have something like this. Yeah? You will not have anything in the quadrant where data is, there's a reason for this, so I'll explain that later. Okay? Because mine is an old one. Yeah.
So please, it seems I'm not getting the 4 windows. I'm getting 3.
Okay, I just solved it. Okay, share your screen. Let me see. Let me help you. Share your screen. Okay, so Michael, you are done with the R Studio.
Yes, please.
Okay, so you have the 4 quadrants, yeah?
Yes, please.
Okay, good. Nancy, you're also done. Okay, excellent. Yeah, who just asked the question that they were having 3 windows? Oh.
Sir, I am the one.
Have you
It's
sorted
working
it
now.
out? It's working now.
Yes,
Okay.
please.
All right. Okay, so you should have something like this, yeah? Okay. All right, that's fine.
Yeah, trusting a more than hour.
Let's go.
Okay.
I can't take you the next one. I might feel like when the screen.
What do you have? Who is sharing? Who is sharing?
Anna, it's Richard. Am I on course?
Richard. Okay. So yeah, click on, you see on your right hand side. Yeah.
Yes.
Okay. You see where the console is. Your right hand side. Take your cursor upwards. Take it upwards. Okay. Take it. No. Bring it. Sorry, your left hand side. You see the 2 boxes here. Here. Okay. Take your cursor upwards. Take it upwards. You see where the console is?
Yes.
Go. You see where the terminal is? Over on the terminal. No, calm down a bit. Calm down a bit. You are going too far. Terminal. And then background jobs. Don't click. I didn't ask you to click.
Oh, sorry.
Click on the console again. Click on the console. Click on the console again. Can you hear me?
Yes.
Yeah. So you see that line. You see where the background jobs is?
Yes.
Yes. Go to your right. The same line. Go to your right up to where these 2 boxes are on your extreme right.
Okay, yeah.
Yeah.
Yes.
Click on it.
Okay.
All
Thank
right. Okay. Who else? Okay. Bedan, what do you have in your 4th quadrant? You say you have some things there.
It was looking like Richard's.
Okay, so you are okay now.
Yes, sir, we are okay.
Okay, all right. So let me explain what you have. Please, are you all done? Can I explain the quadrants?
Hello, Nana.
Yes.
Please, I'm done installing, but I don't know. I thought it would appear on my desktop, but I'm only seeing the R.4 points.
Have you downloaded the R Studio?
Yes, please.
Okay, so probably you didn't check on where it should appear or that it should appear on your desktop. So where you have your search, okay? Search for R Studio.
Okay.
It's one word.
Okay.
And then when it
Okay.
appears, yeah, click on it.
Okay. Okay, so I have three options. Use your machine's default.
Okay, share your
64.
screen. I just
Okay.
showed them how to do it, but share your screen.
Yes, I've shared it.
Yeah, click OK.
No, no. Yeah, that's fine. That's fine. Go ahead.
Yeah.
Okay. Okay.
That's the 64-bit something.
Use a 64.
Crash reports don't include any personal information except for IP addresses, which are used to determine how many users are
No,
affected by
say
crash.
no. Say no.
No, okay.
Okay, and then click on the two boxes you have on your. You see the left quadrant, the top.
Yes,
top right corner. Top right corner.
Yeah.
Top right. You are on left. No. Don't go to the right quadrant. I said on the left quadrant, the top
The
right
middle
corner
one,
of the left.
middle.
Yeah. No, you've gone past it. The two boxes that come to your right. Yeah. That one. Yeah. Click on it.
Okay.
Okay.
So is that all?
Yeah, that's it.
Okay, thank
Very
you.
easy, isn't it? Okay. All right. Okay. So.
Jose,
Yes.
please, I also have a problem.
Okay, Christiana, what problem is it?
I also can't find it. Initially,
Yeah,
I
so search for it. So write RStudio in your search. Okay, it will pop up.
Okay.
Normally, when you are installing, it gives you the option for it to appear on your desktop. So if you didn't check it, then to not show. So now that it's showing, you can just drag it and put it on your desktop. Okay. Yeah. Okay, any other issue? Do we all have it? Do we all have it now?
Yes, please. I have it.
Okay, so let's see some of the basic stuff we find in there. Please, can you see my screen? Install. What can you see? Installing RStudio, isn't it?
Please, you can't see your.
You can't see your screen.
You can see. Okay, just a minute. I think I need to share it here. Which one are you seeing now? Okay, you are seeing the installing RStudio, isn't it?
Yes.
Okay. So we've done this. Okay, so now you all have this, isn't it?
Yes.
Yeah.
Okay. So here, the top left corner, this is where we will enter our commands or scripts. Okay. So this is where we'll enter our commands or scripts. Okay. So you can actually do it down here where you see when we downloaded the console, do you remember that it was only the quadrant below, the one on the left quadrant down there. Just a minute. So when we downloaded the R, that's what it gave us. So when you do the RStudio, it gives you this interactive development environment, IDE. So please, your microphone is on, so you can't. The other class, please, guys, I've told you several times to put off your microphone. You are disturbing the class. Okay, just be mindful. If be checking if your microphone is on, then put it off. Because I'm trying to explain the quadrants to you. You're also talking. How will you understand? Okay. So you have the 4 quadrants here. Yeah, please let me finish and explain this, and then I'll sort you out. Okay, just a minute. So you have the 4 quadrants here. The one on your top left corner is where it acts like your editor. Okay, you enter commands here. When you enter commands here, it will execute on the quadrant below. Okay, normally when you download the R console by itself, okay, and then you execute, okay, when you execute, you cannot go and then, if you make a mistake, you cannot go and then edit it if it's only the console. That is why we normally use the R Studio. So with the R Studio, everything you enter in the editor where the arrow is pointing, if you run a command and there's an issue with it, you can go back and then adjust it a bit and then run it again. Okay, so that is the advantage of the R Studio IDE. Okay, please, was there a question before I go on? Oh, you are saying you can't unmute yourself. Is it giving praise?
I was also having difficulties of the I downloaded it, but I can't find it.
Okay, so search for it. So write R Studio in your search. Okay, on your desktop, you'll find it. Okay.
Okay.
Okay. So that is the test editor. Okay. Let's see other stuff. So here, the bottom left is where your results will be displayed. Everything you enter on the top left will be displayed in the bottom left. So this is the console. Okay. So here, commands cannot be stored. As soon as you put off R, everything here goes off. That is why it is important to run everything here in the editor. With the editor, you can save it and then rerun your commands. Okay. All right. So that is the console for you. Okay. And then on the top right is the environment variable. Okay. We have the environment variables and also the global types. So here it records all the data you are using. So for instance, if I can show you my R Studio, for instance, you see that in my global environment, I have some stuff here. Okay, it's because of the data sets. So these are all data sets I've stored. All right. Okay. And then also some, so it gives you information about what you have run. Okay. What you have run. So we'll come back to this. Yeah. And then we have the one down, the bottom right is where your visualizations will be displayed. Okay, so graphs, plots, and then help information, and also the packages and everything, you will see them here. Okay, so the more we use it, you will see how it operates. Okay, but for now, just be conversant with the R. So just to give you a typical demonstration of my R, let me see. Please, can you see my R Studio?
Yeah, we can.
Okay, so if I enter something here, for instance, okay, so if I enter, let's say 1 + 1, okay, 1 + 1, and then I hit run or control enter, okay, you see that it gives me 1 + 1 here, right? It gives me 1 + 1 here. Okay. And then, so you see that I have the results here. So shown in the console. Please, can you see?
Yes, please.
Yes, sir.
Yeah, we can.
Yes.
Yes, please.
Okay. So you can just try your hands on it. Yeah, we'll do a lot of stuff. Let's say 4 plus 3. Do Control Enter. So it gives you 7. Okay. So you see that I enter it here, and then it gives me the answer here. So I can make a comment here. I'm making a comment. It's a good thing as data scientists, whatever code you are writing, it's good to be commenting so that when another person is looking at it, they can follow your code. Okay, so here I can comment here, okay, that this is the addition of numeric data. So because I have put a hash sign here, okay, this information will not run. Okay, so let's run this again. Have you seen that it has still given me 7? And then this hash sign is telling R that this is a comment, so it shouldn't run it. Okay, supposing I remove this comment from there and then I run it, you see that it's giving me error because this is not a command. Please, do you follow?
Yes, sir.
So whenever you are making, yes.
Does it run everything within the script or just the last one?
You say?
Does it run everything within the script or is just the last?
Oh, you mean the lines? No,
the line of code.
Yeah, the lines.
Yes, it runs the line of code. But if you want to run everything, you can just highlight all of them and then run. Okay. So you see that now it has given us 2, 1 plus 1, and then 4 plus 3. Yeah.
Okay. Thank you.
Okay. Any questions? Any questions on what we've done so far? I don't want to give you so much today. I think it's okay for today. Tomorrow we'll build on this and then move on. Have you all downloaded RStudio? Is it working well? Everything. So tomorrow, as soon as we get into it, no turning back. Any issues with the RStudio, please?
No, please.
Please, mine is still downloading.
It's still download, no problem. No problem. Probably your internet is slow.
Yes, please.
So you take your time and then let it download.
Please, sir.
Hello.
Yes, please go ahead.
Mine is giving me something like maybe upload. Is it crash report to RStudio automatically?
So
I don't know.
you can click no.
Okay. And please, it gave me. I have the interface we are using all right, but it's giving me some. See, when you open a program,
Share your screen. Can you share your screen so that I can see
Okay.
exactly what you are saying?
Please, I'm coming. Please, I've shared it.
I can't see you. I can't see your screen.
Okay. Please, can you see it now?
No. Okay, it's now coming.
Oh, really?
It's
Then
not
maybe
coming.
I
It's
don't
not
know.
coming. Wait, it's not coming. It's now. I think
Okay.
your system is a bit slow. I think your system
Please,
is
can you
slow.
see?
It hasn't come. It hasn't come.
Okay.
So try it again.
All right, sir.
Hello, Nana.
Yeah, Obed.
Please,
Who's
mine is now.
who's work? Just a minute, Obed. Who is it? Christiana's work?
Yes, I think it's mine.
Yeah. Okay. So like I said, so on your right hand, the left hand quadrant. Okay.
Mhm.
You see where the console is.
Yes.
terminal. You see terminal?
Yes, I have seen that.
Background jobs. Yes, go to your extreme right. You see those?
Yeah, they're like the two boxes.
Yeah, click on it. Yeah.
Okay, that's it.
That's it. Yeah.
Thank you very much, sir.
You're welcome.
Please, Nana, I'm done downloading the R Studio, but I can't find it too.
Oh, go to your downloads and then run it as administrator.
I have.
And what is it telling you? Share your screen, let's see.
Okay.
Nana?
Just a minute, let me sort out
Okay.
Please, this is my screen.
Okay, it's yet to pop up here.
So do I need to do something?
I haven't seen it yet. I think that your internet is a bit slow.
The internet.
Your internet is a bit slow, so I'm not seeing anything yet. It still hasn't come.
Hello, Nana.
Yeah, so bad. Yeah.
I just wanted to find out. I'm now installing the Anaconda on my laptop. After it's installed, will I be able to, when it's launched, will I be able to see the R interface like the way we are?
Yes, with Anaconda, it does everything in one go.
Oh,
so you see the R Studio, everything there. Yes. So whose is this?
This is mine.
Okay, so this is a console. Okay.
Yes,
so this
please.
is fine. So when you are finished with this, now go and download, close this and go and download the R Studio.
I have.
So where is the R Studio? So don't open this one. This is not what we are going to. So this is, you see that with the console, this is just one of the quadrants in the R Studio.
Okay.
Okay, so this is not what we are going to use. So close this.
I have, and this is my R Studio.
Okay, so open your R Studio because I'm still seeing your console here.
Okay. Please, I'll share this. Make sure. Please, are you seeing my R Studio now?
Okay, so I can see your R Studio. Okay, are you installing it again?
I've already installed it, but when I click on it, this is what it's showing.
No, you close this. Close this. Okay, so if I can see your desktop, I can see what is there, then I can show you where to look for it.
Okay, so I'll share it again.
Please, if you are done, I think that's it. If you have your R Studio running, that's it. Tomorrow continue. So I'm here to help those who haven't done that yet. So you are free to leave.
Sir.
Okay.
Okay.
So
Thank
please, I was trying to. Hello?
Yeah.
I'm trying to perform the basic arithmetic you did, but it seems my results are not showing down there.
Okay. So let me help give him praise. After that, I'll sort you out. Okay.
Okay.
Yeah. Is that your desktop?
Yes, please.
Oh, so you close this because normally with is it Windows?
Yes, please.
So close this, and then go to your desktop. Go to your desktop.
Okay.
Go to your desktop.
And now, please, those of us who have finished, can we leave?
Yes, yes. Those who have finished, you can leave, please. We'll meet tomorrow
you.
morning.
Okay. Thanks.
Hi, sir.
Please, I'm on my desktop.
No, but you are still, I can see that you have opened the R. Why don't you close it? You are just minimizing it. Close it.
Excuse me, dog.
And just a minute, please. So don't minimize it. Close it well.
You.
Please, I've closed it.
Okay, but I can't see your desktop now. If I can see your desktop, then because normally you go to search and then you enter our studio, it should pop up.
Okay.
I think your internet is quite slow.
Yes, please.
Because now everything is gone. I can't see anything on your screen now. Okay, was somebody asking a question?
Yes.
Yes,
Okay, wait. Okay. Yeah, now.
Okay.
So yeah, so this is Power BI, right? So where do you have your search? So click on your search, come down here. Yeah, click on search and then type R Studio. Yeah, that's it. And then click open. Click open.
I have.
Use the one, click that one.
Okay.
Then let's see what happens. So yeah, so click OK. I think you opened it, you click on it twice, that's why. Okay, so it's coming. Left-hand side, the quadrant on the left-hand side. You see the two boxes on the top right corner?
Yes, please.
Two boxes on the left quadrant.
Corner.
No. Come to your right. Come to your right. Okay. Come to further right. There are two small. No. You are going to the stream. Within the left quadrant, you are in the right quadrant now. Come to the left quadrant. Within right top corner. Right. Come. Right. No. You are going to left. No. Further right.
Come.
In the left quadrant.
Okay, you see where the background jobs is?
Background what?
Jobs.
Yes, background
the
jobs.
Tab. Go to your right. You stay. Go to your go. You go. When I say stop, then you stop. Go to your right. Don't go up. You see two small boxes there.
This.
Give him praise. Just go on your right.
Okay,
No,
I think the boxes beside the environment. Have you seen?
Yes, you see environment. There's a small box before environment.
There are two boxes beside it.
You see where environment is?
Yes, this.
Yes, you've got past it.
I said this first. I don't know if you didn't see it.
Okay, click on it. Yeah, now we are good to go.
Okay.
Now enter anything. Enter 1 + 1. Let me see.
1 plus.
1 + 1.
1 + 1.
And then hit run.
Run.
Yeah. Run is here. come up a bit. Yeah.
Run.
Okay. Have you run it? So it should show on the down. Enlarge your stuff a bit. Enlarge it. Use the full screen. Yeah. So have you seen that the result is down there?
Yes. 1 + 1 is 2.
Yeah. Good. So we are good to go. Yeah. So you can play around with it. You can try anything that you want to try. Okay. All right. Please.
Thank you.
Okay. You are welcome. So please, anybody else? Obed, you were asking a question. Please, are we okay? Is everybody okay? Okay,
Yes.
so please, if you finish sharing, you can go off. And
Yes, please. Thank you.
Okay, you are welcome. Okay, anybody else? Anybody else? Are we okay? You should have something like this in your stuff. Yeah. All right. So if we are okay, then let's make it tomorrow morning. Okay.
Hello, sir.
Yes.
Sorry, I think I was talking, but my mic was on mute.
Okay. Please go ahead.
Can I share my screen to show you something?
Please do. Please do. Yeah. Okay. Louisa, right?
Yes, please.
Okay. Yeah. So so this is your R console, is it not?
Yes,
So
sir.
open. Have you downloaded the R Studio?
Sir, please, I was unable to download it.
Why?
It just came as a file, and then when I was opening it, it was not opening.
Okay, then you need to download it again because we can't work with this one. The R Studio is built on this. Okay, so try again and then no. Okay. So yeah. So download R Studio. Is your machine a Windows machine?
Yes, please.
Yeah. So click download R Studio for desktop for Windows.
Yes, please. I've clicked on it.
Okay. Right. Okay.
So it comes as unconfirmed.
Yeah.
Oh, hello, Nana. It seems he already has the R Studio.
Where is it?
I was
At
about
the
to go
right,
through that.
top
Right next
right.
to the Dubai
Top
Airport
right. I can't see.
right next to the Dubai Airport pickup, first row.
I can't see the R Studio.
No, the setup file seems to be there.
So say I just have to wait for it to finish downloading.
No,
Yeah.
so hello. So 1, 2, 3, 4, 5, 6, 7, 8 icon. The 8th icon at the top row.
Hello.
The 8th icon at the
Guys,
top
let's
row.
do it one person at a time so that we can follow.
Hello.
Please, yes, Louisa.
Yes. Say please. So I was saying, so I just have to wait for it to finish downloading.
Exactly, yeah. But somebody said they saw R Studio on there, but I didn't see it. So wait for
R
it to finish.
Studio.
Yeah, so wait for it to finish downloading and then you can install it. Yeah.
Okay.
I think your internet is slow. Okay, anybody else? Joshua, were you saying something?
Oh no, I was just pointing to the RStudio that's already downloaded onto her desktop, onto her in her.
Oh, so I didn't see the RStudio on there. Did you see it?
It was the top, yes, the top right. That in her
I'm
file
sharing my.
explorer.
Okay, Louisa, share it again. Let's see.
In her file explorer, the top right of the first row.
Okay, so where is it? Top right.
First row, the last but one icon on the first row to your right.
No, but that is not RStudio. That's not how it should come out. It should be a big R. It shouldn't come out like this.
So sir, please, I shouldn't install this one.
No. Wait. Then that means that welcome to our. Oh, so this is the setup. Okay, then that's fine. Because normally when it's done, it gives you another. Okay, so go to next. Okay, all right. Okay, that's fine. So that's the setup. That's fine.
Yeah.
Okay.
So that means the one that is downloading, you can get rid of it later.
Okay.
Okay, so click finish. Okay, so you see that RStudio has now come down there. I think is that RStudio? So search for it.
First.
No. This one is another one. The one that it downloaded. So there's no need to. So come to where the search is. Come down where your search is. Yeah, and then click write RStudio. Look for RStudio. Yeah. Okay. So click open. Yeah. Okay. No. Okay. Now there's these two boxes on your left quadrant. The topmost right of your left quadrant. You see where you have the console? Click on it. Yeah, okay, good to go. So try 1+1 and let's see. Maximize the screen. No, not that one. That one will reduce the quadrant. Okay. So when you 1+1 and click on run. Run. Yeah. So you see that it has run it. So you can see the result in your console. Yeah. Okay.
Thank you very much.
You're welcome, Louisa. Please, anybody else? Are we all done? Are we all done? Okay. So if we are all done, then let's meet tomorrow morning. Okay. Okay. Have a very lovely day.
Thank you very much, Nana.
Okay.
Thank you very much.
So class prefect, please send me the list later. Okay. So I'm sure when you get it, then I can send the slides. So probably by tomorrow morning you can get everything. Yeah.
All right, sir.
Okay. All right. Cheers.